Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone.
Waalaikumsalam, Madam.
Good afternoon,
Madam.
Okay,
Good afternoon, madam.
hi. So this is week number 12. So I would like to continue moment distribution method. Okay, this week we will cover, I will revise back what we have learned last week before we continue with beam with the effect of support settlement. Okay, as I explained last week, okay, we go through this first before we continue with example. Okay, the basic definition, fixed end moment, these are all the formula, okay, for fixed end moment. Okay, we have several cases of intermediate loading, okay, such as triangular load, okay, UDL, okay, UDL, half of the member, okay, we have the triangular load like this, okay, as well as point load, okay, 1 point load, 2 point load, and 3 point load. Okay, normally we will only use several type of this FEM type, okay, this beam type in order to calculate FEM. Okay, so by looking at the diagram, we can see that the direction of FEM is actually based on the behavior because whenever the beam is loaded, okay, the beam is loaded, the beam will bend, so the moment will push both end, okay, so that it will move back to its original position, which is straight position. Okay, straight position. This is about the fixed end moment. Okay, and then we move to, okay, in order to calculate the end moment, which is the objective or the goal for moment distribution method, so we need to start with identifying the stiffness factor. The stiffness factor relate with the flexural stiffness, which is EI over L. Okay, EI over L means that the stiffness factor influenced by the material properties, which is come from modulus of elasticity, as well as the cross-section area. Okay, from the cross-section area, we will identify the moment of inertia. Okay, and from the stiffness factor, we need to determine the distribution factor. The distribution factor DF. Okay, distribution factor DF. DF is actually K divided by total K. K for member. Okay, K for member divided by KDF is K divided by total K. Total K, this total K representing the joint moment. The joint moment. Okay, carry over factor. Unbalanced moment are carried over to the other end. Okay, whenever we want to carry the moment value, we have to carry the value to the other end or opposite end of the member when the joint is released. Added to that, the ratio of the carried over over moment at the other end to the fixed end moment of the initial end is the carryover factor. Okay, carryover factor, there are two value. Okay, there are two value for carryover factor. Okay, for end fixed, we use 0.5. Okay, and for another one is for end pin roller, it is equal to 0. Okay, basically in the table, whenever n is pin or n is roller, it is just like we don't carry the moment. Actually, we carry the moment by times with the factor 0. That is why we get 0. Okay, sign convention. Okay, for the sign convention, any moment acting clockwise is considered positive. That is why at the beginning of the analysis, we will assume that this is the moment, no, the end moment for each members, for each element. That is why whenever we compare with the fixed end moment, which is the moment come from the behavior. Okay, so then we compare these two, then we will get one FEM is negative, one moment is negative, and another one is positive. Sekejap eh. Okay, if you have any question, you can unmute and ask a question. Okay. Uh, for okay, this one we still analyze beam, but for frame structure, we will also use the moment distribution method. Okay, for the case of frame with and without. Okay, with and without side sway. Okay, side sway using moment distribution method. Okay, how to do the analysis, the procedure? Okay, number one, we have to restrain all possible displacement and then calculate distribution factor. Whenever we want to calculate distribution factor, we must determine first the stiffness factor. Okay, these are the two stiffness factor, okay, that we can use in order to solve all type of questions, okay, for beam and frame analysis using moment distribution method. Okay, for fixed end and internal member, we use 4 EI over L. And for end pin or roller, we have to use 3 EI over L. And for the distribution factor, it is equal to K divided by total K. K means the K for element, okay, member stiffness divided by joint stiffness. Okay, and the carryover factor 0.5 and 0. Okay, next, calculate fixed end moment. This could be done, okay, due to loading, okay, temperature variation, as well as relative displacement between the end of a member. Okay, the one that we have done last week is due to the loading. Okay, due to the loading. And then we need to do distribution cycle for all joints simultaneously. Okay, the process in the table will be done simultaneously, and then we will do it cycle. Okay, cycle by cycle. Start from distribution, and then we continue with carryover, and then we repeat the process again and again. Okay, until we get the value reaches 0. The value in the table means that the moment value in the table reaches 0. Okay. Finally, we will calculate. We will calculate the final end moment. This one, final end moment. Okay, of each member. This is the sum of all moment, including, don't forget to include FEM, because FEM is, as I mentioned last week, FEM is actually the first. Okay, FEM is first member and moment. Okay, first member and moment, or first internal moment. Okay, member and moment is also called as internal moment. Internal moment. So we need to calculate, okay, to calculate the value. The value start from the first fixed end moment in the table. Uh, the first value, okay, the first moment value that we need to consider must be started from the first fixed end moment. Okay, the first after distribution is fixed end moment, so that is the first member end moment value in the table, and then we start with distribution, then followed by carry over, repeat back to distribution, carry over, distribution, carry over, distribution, carry over, and we end at distribution. Okay, we must end at distribution, and then we must total or sum all the moments start from the first fixed end moment, okay, until the last distribution, and then we will get the member end moment for the beam we analyze. Okay, this is one question. I am taking this, okay, from example given in one website, structural analysis website. Okay. Okay, this is the beam. The member AB, and yeah, member AB, BC, CD have the same length. The length for each member, okay, is given as 10 meter. Okay, so yang ni 10 meter, ni pun 10 meter, ni pun 10 meter. Okay, next. Okay, the flexural rigidities are EI, 2EI and EI respectively. So, flexural rigidity, okay, for this beam, EI, 2EI, EI respectively. Okay, and then concentrated load. This is also P. Concentrated load in unit kilonewton. This is also P. Okay. Act uh, at a distance. At a distance. Okay. At a distance, dia macam ni. Total length is 10 meter. Total length is 10 meter. So this P is subjected not at the center, but 3 meter. Okay, 3 meter from the first support, the first support. Okay, so this one, this is P 10 kilonewton. 10 kilonewton, the distance. So here is A, here is B. This one is B, A and B. So A is equivalent to 3 meter. A is equivalent to 3 meter. So the remaining is 7, 7 meter. Okay, 7 meter. Okay, from support A, from support A, uniform load of intensity Q. Okay, tengok pada unit Okay, unit is in kilonewton per meter, means that yang ini this one 10 kilonewton, and then we have 1 kilonewton per meter here. Okay, of magnitude 1 kilonewton per meter. This is 1 kilonewton per meter. And then member CD is loaded at its mid-span. Mid-span means at the center. At the center, the loading is also 10 kilonewton. This is also 10 kilonewton, and the distance. Okay, the distance is, this is 3 meter, this is 7 meter, 10 meter, 5 meter, and 5 meter. Okay, so what we need to do now, we will analyze this beam together. Okay, the first one we will analyze without settlement. Okay, first one we will analyze this. Analyze this beam, analyze the internal moment. Internal moment Okay, internal moments means there are six internal including 0 moment at A because A is roller. A is roller. Okay, and this is the basic one. And number two, we will look at to the support settlement. Okay, analyze. Yang ni due to load lah. Load shown. Okay, and then another one we will analyze internal moment. Okay, by considering. Okay, support settlement at, for example, B. Okay, B. Yang ni support settlement ni, for example, B ni 30 M. Okay, we do it one by one. Number one, we will analyze the internal moment due to load shown. If you have any question, okay, please unmute and ask question. Okay, number two, we will analyze internal moment by considering support settlement at B. If the settlement is 30 mm. Okay, settlement means downward. Okay, so we go back to this. Okay, we have to study the condition of this beam first. A is fixed. It means that, okay, here we must consider the far end condition. This is end roller. A is bukan fixed roller, sorry. Okay, A is roller end. So the far end for AB, okay, is roller. Okay, and B and C is internal member. So for K, we need to use 4EI over L. And then for CD, we need to refer to D as the far end, and it is fixed end. Fixed end. Okay, fixed end. Okay, any questions so far? So any question?
No, madam.
Okay, so I will move this to Excel so that we can calculate the end moment using Excel. Okay, wait, okay. So there are six. Basically, we know that the. Okay, sekejap azan. Okay, we continue. In the table, we have 6 member and moment start from A, B, even though A is roller N. Okay, start with A, B, B, A, B, C, C, B, C, D, D, C. Even though A is roller N, so we will get the total moment at this column is equivalent to 0. Okay, 0. Okay, so there are 4 join. Okay, we have join A, and then we have join B, join C, and C, and D. Okay, there are 4 joins. So it is important to identify join because we actually distribute the join moment, not the member and moment. Okay, join moment, not member and moment, and join moment is always opposite with member and moment. So we will start calculate the K. Okay, K here. K in terms of EI, because EI will be cancelled whenever we calculate distribution factor. Okay, for AB, BA, we need to refer to... Okay, we need to refer to N condition, N roller. So for AB, we have to use 3EI over 10. 3EI over 10, 3EI over 10, and then EI here is 1. Okay, so it is 3 over 10. Okay, this is 3 over 10, 0 0.3, yeah? 0.3. Okay, this is the same value because it is the same element. Remember that the stiffness factor is for element. AB and BA is the same thing. Okay, is the same thing. So for member AB, we only have one stiffness factor value. It is equal to 0.3 because we use the formula for 3EI over L because of roller N. Okay, at A. Okay, then we move to member BC. Member BC 2EI. It is 2EI. 2EI. So it is... Okay, this is internal member. So we need to use K. So for K, K2. Okay, for K2 or KBC. So it is 4 times 2. EI. Okay, 4 times 2, 4 EI times 2, 4 times 2 EI divide by L. L is 10. Okay, it is 0.8. 0.8 EI. So this is 0.8. Okay, it is 0.8. Same value. 0.8. Okay, 0.8. Okay, next is... Okay, fixed, yeah, fixed, and fixed D is fixed, so we use 4 EI over 10. It is 0.4, 0.4. So here is 0.4, 0.4. Okay, now we will calculate distribution factor. Distribution factor for N roller is equivalent to 1 because N roller is the end of the structure, and distribution factor for N fixed is 0 because for n fixed, okay, the k value is divided by infinity. So fixed distribution factor is 0. Okay, and we have another two join B and join C. And remember, the total moment at join is equal to 0. Equal to 1. Distribution factor is equal to 1 for all join except fixed n. Except fixed n. Okay, so we calculate the value. It is 0.3 divided by 1.1. Okay. And then it is 0.8 divided by 1.1. And then we have 0.8 divided by 1.2. And then we have 0.4 divided by 1.2. Okay. Okay, I want to set up to 3 decimal places. Sorry, 3 only. Okay. Okay, next is fixed end moment. Fixed end moment. Okay, for fixed end moment, actually we can also refer to the okay, in the textbook. Okay, I don't put the formula from textbook here. Actually, in the textbook, wait, not this one. Yang ni. Okay, actually in the textbook at the back, okay, page, the last page of your the cover page of the textbook. Okay, for the fixed end moment, okay, there are two condition of fixed and two condition of for n. Okay, consider whenever we want to calculate the fixed end moment. Anyway, for the analysis, we can also use only one formula, means that we first assume that both n are fixed, and then we will analyze as usual. And don't worry, at the end of analysis in the table, we will get the moment at A, which is at roller n will equal to 0. Okay, so for the first AB, for the first member, okay, A is equivalent to 3, B is equivalent to 7, so we need to use this formula. Okay, we need to use this formula. Okay, please calculate for me when P is 10, A is 3, B is 7. Okay, please calculate for me the fixed end moment using these two formula. Okay, please calculate for me. We assume that both n are fixed. Okay, please calculate for me. Whenever P is 10, A is 3 meter, B is 7 meter. So please calculate for me FEM for AB. What is the answer?
14.7.
14.7. Another one? Another one, FEMBA.
6.3.
6.3.
6.3, 6.3. So it is negative 14.7 and sorry, 6, not 9. 6.
6.
Okay, 6.3, So it is negative 14.7 and 6.3.
3.
Yes.
Yes.
Okay, 6.3. Okay, so okay, next for member B. Okay, for member BC, W is 1 and length is 10. Okay, this one. This is equal to 1, length is equal to 10. So what is the fixed end moment for AB and BA?
8.3.
8.33.
8.33 ya.
Yes.
333 miss. Kan?
333 betul.
333. Okay. Okay, another one is PL over 8. PL over 8, right? P is 10. L is also 10.
$12.5.
This is negative 8.333, yeah? And 8.333. Okay, so we have put all the fixed end moment into the table. Okay, into the table. Okay. Like this, yeah? Okay. So remember the first moment in the table is actually the fixed end moment. Fixed end moment. Okay, fixed end moment is the first member end moment. The first internal moment in the table. In the table. So we will start with the first distribution. We will start with the first distribution. This is distribution number 1. Okay, distribution number 1. Remember the process. Remember the process where we need to distribute the join moment. We need to distribute the join moment. Okay, we need to distribute the join moment, and join moment is opposite with member and moment. Okay, if FEM for AB is negative 14.7, so join moment for A, for join A. What is the join moment for A?
8.4.
Okay, A, this is AB. Okay, this is AB. The moment is 14.7 and 6.3, right? Like this, right?
Yes.
This is 14.7. Okay, this is member. This is fixed end moment, and fixed end moment is the first member end moment in the table. But the moment that we distribute is join moment, not member end moment. So join. Okay, here is A. Okay, the value that we distribute is actually this value. This is also 14.7, right? This is join. Okay, this one is join. Ni join. This is member. Okay, so the moment that we distribute is actually the join moment, and join moment is opposite with member and moment. So join moment, the join moment at A is negative 14.7 or positive 14.7. Which one? Mana satu? Ini ke join moment or yang ini join moment? Which one? Pink or blue?
Green eh.
Nampak green eh?
Pink.
Green.
Positive.
The positive one is join moment because the member and moment and join moment opposite condition. Okay, the moment that we distribute, at distribution level ni, now we calculating the moment at level distribution, right? Okay, the moment that we distribute is actually not negative 14.7. Negative 14.7 referring to this. Sorry. Referring to this. 14.7 is this. Negative 14.7. Okay, stated at the FEM column. But the moment that we distribute is not negative 14.7, but the join moment. Where is it? This is the join moment. And join moment is always opposite with member and moment. So the value that we use to distribute is 14.7. So for this 40.7, this 14.7, we need to calculate with distribution factor. And in this case, the distribution factor is equal to 1. Okay, I bring this to the other side. Okay, everyone must understand this. Okay, everyone must understand the process in the table. Okay, the process in the table. Okay, any question? Do you have any question?
No, madam.
Okay, so the value that we should put in distribution column for AB, what is the value? What is the value? What is this value? Hey. It is 14.7 times. It is 14.7. Okay, it is negative. Okay, this is actually FEM, right? FEM, this representing opposite condition. Betul?
Betul.
Is it right? Okay. I put negative, okay, outside the bracket, okay, represent the opposite condition. The opposite condition, which is referring to the joint moment. Okay, the FEM is negative 14.7. The formula is distribution. To calculate the moment, we have to calculate. We have to times the moment with distribution factor, and distribution factor for A, B is equivalent to 1. Times 1 times sekejap. I need to plug the power sekejap. Okay. Okay, this one ni apa dia? One ni is, this is distribution factor. Distribution factor. Okay, this is the process whenever we distribute moment. Okay, we put negative to represent the opposite condition. Okay, the opposite condition means that the moment at join, which is opposite dengan member and moment, and then fixed end moment negative 14.7 times with distribution factor. For AB, the value is 1. So that is why for in this column we should put the process negative. Okay, choose FEM negative 14.7. Okay, times with 1. 1 is the factor. Okay, 1 is the factor. 1 is the factor. I put this sign to lock the Distribution factor. Okay, siapa yang tak faham at this stage, the process whenever we distribute moment. Okay, kelas?
Madam,
Ya?
yang tolak dengan 6.3 tu, madam?
Okay. Which one? Yang ni?
Macam mana, madam?
Ini ke? Yang ni ke?
Yang tidak kena tolak kan, madam?
Okay, we will calculate, we consider joint by joint. Now we are looking at A first. This is A, right?
Okay, madam.
Okay. Now we will move to B. Now we move to B. So this is B. Okay. And then we move to C. This is C. And then we move to D. We do it one by one. This is D.
Okay, madam.
Okay. So the one that we have done just now, okay, is only focusing on joint A. Okay, joint A only. Okay, now we will move to joint B. Now we will move to joint B. So, okay, yang ni saya tak padam. Saya just move position so that you can refer after this. Okay. Okay, yang ni. This is A lah. Joint A. Okay. Okay, now we will calculate the distribution, the moment distribution number 1, the moment. Okay, the moment we want to distribute to BA and BC. BA to BC. So the fixed end moment for B, so you must understand this. BA and BC, we have like this. Okay, this is joint B. Okay, now we have here is BC. Another one is AB. A, B. Okay, so from the fixed end moment, we have 14.7 and 6.3. This one is 14.7 and 6.3. Okay, clear that one? And for clear that one? Clear that one? For AB, the fixed end moment that we calculate. Okay. So, okay, for BC we have okay, for BC we have 8.333 and positive 8.333. And this is for joint B. This is joint B. Remember that the moment that we distribute, at distribution level is actually the moment at joint B. So how to get the moment at joint B? How to get the moment at joint B is actually, okay, remember that for joint, the moment, okay, the fixed end moment is the internal moment in the table, internal moment or member end moment. And member end moment opposite with joint moment. Joint moment. So the process is actually like this. Okay. So Okay, just draw the moment direction which is opposite with the moment. Okay, the fixed end moment. Means that for B, at joint B, we have the moment acting in this direction because it is opposite with the FEMBA, isn't it? Opposite, right?
Yes. Yes.
Okay, and then another moment, okay, another joint moment is actually come from the fixed end moment, which is FEMBC, FEMBC, and it is actually opposite with FEMBC. So if the direction of FEMBC is in this direction, so we have to put another moment direction which is opposite with this one. Okay, so we have this. Okay, look at the blue moment direction. Okay, the blue moment direction. So the moment that we distribute is the blue moment. Okay, the blue moment. So what is the process? What is the process? It is actually okay. So the process in the table is like this. It is negative to represent the opposite condition of joint moment, negative to represent the opposite condition of joint moment. Okay, and then the value we get from this. We get from okay, the value we get from this 6.3 and negative 8.333. Okay, it is 6 point. Okay, it is 6.3. Okay, 6.3 and negative 8.333. So plus minus kan 8.333. Okay, and this joint moment we must times with distribution factor for BA. Distribution factor for BA is distribution factor for BA is 0.3. 0.3. So here is actually 0.3.
Madam,
Okay, yeah.
itu bukan K dia kah?
Oh, screen
0.3.
Okay, 0.3, yeah, 0.3. Okay, the process in the table is like this. Okay, negative, this negative. Okay, this negative representing opposite condition. Opposite. This is opposite with this is the joint moment. Okay, the moment direction for joint moment is opposite. So we put negative to represent joint moment, which is opposite with member and moment. And then 6.3 and negative 8.333 we get from the fixed end moment in the table. 6.3 and negative 8.333, the total moment. The total moment. And the moment, okay, to get the value for this, we must times with distribution factor. We must times with distribution factor. So the process is like this, yeah. The process is like this. Okay, so we put negative. So this one we put negative, this negative, right? Negative. Okay, negative we put to represent the condition of joint moment, which is opposite with member and moment. And we total these two value. Actually yang betul is negative 6.3 because yang ni negative 6.3. Nampak tak? Kejap. Okay, actually this is 6.3 which is negative, right? And this is 8.333 which is positive. That is why the total moment we get 2.033 total moment. So the moment that we distribute is opposite with member and moment. Member and moment tu opposite. That is why whenever we want to solve the value, we put negative to represent the opposite tu. Tapi sebenarnya the moment that we distribute is actually okay, the blue, okay, the moment, okay, yang the blue one. Okay, the moment is negative 6.3 plus with 8.333. That is why we get 2.033, the joint moment. Then only we calculate, we put times with distribution factor. Yang ni silap, yang ni 0.273 distribution factor. So this one is 0.273 0.273. This is 0.273 is the distribution factor. This is actually the distribution factor. Okay, so this 2.033, this 2.033 is the joint moment. How to get this? It is 6.3 minus 8.333. Change sign to represent the opposite condition. It is 2.033 is only the joint moment times with factor. The factor is 0.273. Okay, yang ni factor dia. Is it okay? Is it okay?
Okay, madam.
Which part yang tak
Okay,
faham?
madam.
Okay. So we repeat the process again. So I put negative to represent the opposite condition, and then total is total this plus with this. Okay, get the joint moment whenever we put negative. Okay, times with distribution factor 0.2727, 0.727, 0.727. Okay, this. Okay. And we can check these four values, okay, must equivalent to 0 because M, the moment at B, moment at joint B, because B is roller support, the total moment must equal to 0. Kiralah total tu 6.3 minus 8.333 plus 0.554 plus 1.479. Do you get 0? Do you get 0?
Dapat, madam.
Okay.
Yes,
So
madam.
same goes to the previous one. Same goes to the previous one where M at A is equivalent to 0. It is negative 14.7 plus 14.7. Okay, now this value are also 0. Okay, so we continue the process. Okay, continue the process. We move to joint C. So I put negative, and then total moment. So just choose CB plus CD. Okay. for C. Okay, for C means that the moment that we consider at joint C is actually negative 8.33 and positive 12.5. Okay, but in this calculation we have put negative to represent that one. Okay, times with 0. Kejap, 0. Okay, 0.667 0.667. 0.667. Okay, this, and repeat again, we put negative. Okay, total, this one and this one at the same joint, times with 0.333, 0.333, and again. Okay, please check these four value. Do you get 0? Do you get 0? The blue. Okay. Do you get 0?
Dapat, madam.
Okay. Okay, last one is join D. Join D because the factor is 0. Because the factor here is 0. Okay. Because the factor is 0, so the value is 0 lah kan. The distribution is total moment at D. Total moment at D 12.5 or negative 12.5? Total moment at join moment at D.
Negatif.
Yes, it is negative 12.5. Join moment at D is negative 12.5. But this time, the distribution factor for DC is 0. Okay, and remember, we don't need to put 0 value in the table. Okay, we don't need to put 0 value in the table, so just leave it blank. Okay. Is it okay?
Okay, madam.
Yeah, so I bring this. Okay, later on I will put this in the Teams, yeah. Okay, so next is carry over. Okay, at this stage, carry over. Okay, we must carry the value to opposite joint, means that it must carry, cross boundary. Okay, cross boundary means that B, we need to carry the value to A, we need to carry the value to B. Okay, B to C, C to B, C to D, D to C. Okay, but we need to consider the factor. Okay, we need to times the factor. And remember, for end roller and pin, the factor is 0. For internal as well as end fixed, the factor is 0.5. Okay, so actually the process is like this. Okay, boundary. Mana boundary? A and B. So like this. Okay, carry the value to opposite. So B and C here. C and D here. Okay, it means that each value, we must times with with carryover factor. Okay, so let's look at this together. Okay, the value that we need to carry to B, the value at A, the moment value at A that we need to carry to B, okay, come from 14.7, and because B is internal, and internal is assumed as fixed, so internal we always use 0.5. Internal we always use 0.5. So it is 14.7 divided by 2. Dapat apa tu?
7.35.
7.35.
Okay, this one is 14.7 divided by 2. However, the value, okay, the moment value for BA at column BA, this one at column BA, this value, okay, at column BA, because the factor is 0, two roller, two fixed, the factor is 0.5. Internal is 0.5. So 2B tu, A to B tu is internal. Internal is fixed. So 2 fixed, it is 0.5. So yang zero value ni, zero factor ni is always referring to the end joint. Okay, referring to A lah. Okay, referring to A. So B to A, we use BA. So it is a zero factor. So the value is? The value is?
0.
0. Macam ni lah, 0. 0. So the rest of, okay, except this one, the rest are 0.5. Okay, so we continue. Put this divide by 2. Okay, cross it must cross boundary, divide by 2. Okay, this one we get 0 because the moment is 0, and this is, okay, this one is 1.389 divided by 2. Okay, this and this. So set to 3 decimal places only. Okay, faham yang ni?
Faham.
Okay, these are actually the process. Okay, these are actually the process. Distribution, we must understand, okay, what is the process whenever we want to distribute moment. Okay, the moment that we distribute, okay, is actually the joint moment which is opposite with member end moment. We must times with the factor. The distribution factor, the factor that we calculate from the stiffness factor. Okay, and then after distribution is carry over. For carry over, the carry over level, we have to times the value, the moment value from the previous distribution. Okay, from the previous distribution, we must times with the factor. So if the end of the structure, okay, the end of the structure is roller or pin, so the factor is 0. Okay, the remaining is all 0.5 in this case because internal assume as fixed and D is also fixed. So the rest is all 0.5. Okay, so after that we will continue the second distribution. Okay, we must to repeat this process again and again until the value in the table, until the last distribution reaches 0. Okay, reaches 0. So we just need to copy. Okay, we just need to copy. Okay, I copy this. Okay, these two. Okay, I click copy and then I paste. Okay, this is for the second cycle. The third cycle. Okay, the fourth one. The fifth one. And we can also add another cycle. Okay. Okay, so we have carry over and then distribution number 3 and then carry over and then we have distribution number 4 And then carry over distribution number 5. Carry over distribution number 6. Okay, we may stop whenever the value reaches 0, 0.000. When we meet 0.0, then we may stop. Okay, the previous one we get 0.1, 0.12, right? Then continue another cycle until we reach 0.0 here, 0.047. Okay, actually if you want to continue also doesn't matter because it is just the Excel. Excel, just repeat the process until the value reaches 0. Okay, so remember that the last must be distribution. So the last one we clear content. Okay, the 0 value we don't need to put in the table. Okay, clear also this one. Okay, clear also this one. So this is the last. Okay, the last distribution, and then what we need to do now is to sum all the moment values start from FEM. Start from FEM. Start from this. Okay, start from this until the last distribution. Okay, start from FEM until the last distribution. So this is N moment. N moment. N moment. Okay, so the total moment at A, MAB or MA total is 0. So is it equivalent to the real condition where the N is roller? Yang ni?
Yes.
Okay.
Yes.
Okay, next is MBA as well as MBC. Remember that moment at B, okay, moment at B also equal to 0. MBA plus MBC is equivalent to MB, and MB is also equal to 0 because of the roller support. Okay, so start from 6.3 ni. Okay, until this. So the total is 1 positive, 1 negative. Okay? 1 positive, 1 negative. Okay. Okay, clear?
Clear.
Okay, next MC, MCB plus MCD, again MCB and MCD, we will get the same value in opposite condition. Okay, 10.203, 10.203, 1 positive, 1 negative. Okay, representing this one. Okay, moment at C is equal to 0. And last one, moment at D. At D, it is 13. 13.65. 13.65. Okay. Any question regarding this? This is the end moment due to the load given. Okay, for this beam. Okay, ada yang nak tanya soalan tak?
Tak ada, madam.
Okay, clear? So moment distribution method. Okay, these are actually the process. Okay, these are actually the process. So in this example, because the NA is roller. Last week we have discussed whenever both N means A fixed, D also fixed, right? Okay, this time one is roller, another one is fixed. Okay, the same process is the same process. If D is pin, then only the moment at D will equal to 0. But this example, D is fixed. A is 0. A is a roller, so we will get the moment at A equivalent to 0. Okay, moment at B total is 0. Moment at C equal to 0, and D is N fixed. So N fixed, logically for N fixed ada moment ke tak ada moment? For N fixed.
Ada.
N fixed,
Tak ada.
moment at fixed N.
No.
Ada.
Ada moment lah kan, cantilever beam, remember? Cantilever beam, ini fixed kan? You put the free body diagram. Free body diagram like this, right? Fixed N. Simply
Yeah.
supported beam. The free body diagram. We don't put moment here, right?
Yes.
Okay, why we don't put moment at roller and pin? Why? Because moment here is 0, moment pin and roller is 0 kan? And then why we put this? Ada value, right? Unknown value, right?
Yes.
Yes.
Yeah. So if the N is fixed, of course it has moment value. If moment is 0, then it is actually not the fixed N. Okay? So that is why we get this value 0, 0 value at A and 13.65 value at D. Okay. Any question? Any question?
No, madam.
Okay, clear? So you must understand the process. Okay, the process you must understand. Okay, because okay, of course, in this method, moment distribution method, compared to the previous method that we have learned, this is actually the one of the method, okay, that can be used to analyze quite complex structure, complex structure, because we can have this is only 4 members. We can have more than 4 members, and even though it have more than 3 members like this. Okay, more than this, the process will be the same. Repeat and repeat the process again and again, and all this calculation can be put, and we set the formula, and from that we will determine the values. Okay. Okay, is it? Okay. So, can we have time to discuss a bit about the settlement? We continue about 15 more minutes, can we?
Yes.
Can we
Yeah.
continue about about 50? Okay,
Yes,
I
madam.
plan to explain about the settlement, the concept of settlement, and then for the because the process will be the same in the table, except now we need to consider the settlement. The settlement whenever we want to calculate the fixed end moment. So fixed end moment is actually come from two condition. Okay, fixed end moment. One is come from load. Okay, load, and another one come from delta. Okay, come from delta. Two condition. Okay, two condition. Now we will move to the second effect. Okay, the second condition of fixed end moment, where we will consider the settlement. Of course, we still have the load on the beam, but we must consider the effect. Okay, the effect, and the effect of settlement will contribute to the output, to the analysis of beam. Of course, it will give influence to the displacement, to the internal forces, as well as to the reaction of beam. Okay. So the concept first, yeah. Okay. Okay, let me share again the screen. Okay, the answer is correct, yang ni. 13.65 just now. Okay, okay, after this, using the result that you have that we have got just now, just draw the shear force diagram and bending moment diagram. Okay, now we will move to the effect of support settlement. Yeah, the effect of support settlement. Okay, I have set the settlement. Yeah, the settlement occur at B. The settlement occur at B of magnitude 30 mm. So settlement downward. Yeah, settlement downward. So in order to analyze this settlement, so due to settlement, we refer to the formula. Okay, the formula for, there is only one formula to consider settlement. For example, both and fixed like this. Okay, both and fixed like this. This is A and B, but this time B is settled. Okay, this time B is settled like this. Okay, so the distance between B to B prime after settlement, means after settlement B move to B prime. Okay, because this is the beam, this is beam, and beam is a horizontal member. B is a horizontal member, so delta will be measured perpendicular with member, perpendicular. So go back to the concept of shear, where the delta or the deflection or the displacement, okay, induced by force. Okay. Okay, back to the concept. So it is perpendicular, perpendicular. So this is the delta. Delta. Okay, this is the delta. Okay, both ends are fixed. Assume that both ends are fixed. Okay, this is the formula. This formula is actually given in the cover of the textbook. Okay, later on I will put the formula in this OneNote. Okay, so delta, this is L. This is L, yeah? L, delta. Okay, so remember that the fixed end moment is actually the behavior. Okay, behavior. It means that whenever the movement, okay, the movement from original position to new position, to means that the incline one, yang ni after settlement. Original is horizontal. Original is horizontal. After settlement, okay, after settlement, this is after settlement. Okay, this is after settlement. Original is horizontal because this is original. This is original because beam is always horizontal member. Beam is always horizontal member. Okay, after settlement, it will become like this. Depending on the delta, if B is settled like this, if A is settled, okay, if A is settled, B is remain, it will become like this. Okay, depending on the settlement. Okay, so we refer to this. Okay, so our reference line here is horizontal line. Horizontal line. Because this horizontal line is actually the original position. Original position. Okay, this is the delta. Okay, and the delta is perpendicular to the member. Perpendicular. What we need to look at now is actually how the moment behave in this case. If in the previous case, we have FEM like this whenever the beam is subjected, okay, to point load, the beam will bend. Okay, the beam will bend. Okay, the beam will bend and the moment acting like this due to the behavior. Okay, due to the behavior. Now we have, okay, after settlement, the behavior is like this. Like this. Yang ni. So this beam must, the moment will push the beam to its, the moment will push the, okay, the beam, the inclined one, means the new position of beam, to its original position. The moment will push both ends. The moment will push this A, the moment will push A and B to its original position. The moment will push A and B so that the beam will move back to its original position. And the movement is actually the moment direction. So dia arah mana? The movement. How to get back to straight line? How to get back to straight line? Whenever we have this, how to get back to straight line?
Clockwise. Moment.
Clockwise, clockwise, or anti-clockwise?
Anti-clockwise.
It is anti-clockwise. Okay, then only it will move back to straight. Kan? Logic? Is it logic?
Logic.
Yeah.
Madam.
Okay. And can you realize that for FEM due to settlement, due to delta, both direction of moment are same. Nampak tak? Both moment direction are same.
Yes.
Okay. Okay, the moment at A and B, okay, at A and B are counterclockwise in order to push both A and B to its original position, to straight position, to horizontal position. Okay, so in simple way, you just need to understand like this. Okay, the behavior is like this. From its original position, original dia macam ni. This is pushed to new position by an angle. This is delta, right? This is L. Okay, this angle is called as, simbol dia like this, ada in the textbook. This is called as chord rotation. Okay, this is called as chord rotation. This is called as chord rotation. And see the behavior from its original position. From its original position, look at the direction. From original means in this direction. The direction, the angle, okay, the direction of chord rotation. Okay, from original to new one. Is it clockwise or anti-clockwise? The angle.
Clockwise.
Okay.
Clockwise.
The angle, both angle are clockwise. Because this is actually the simple maths where here is the reference line and this is zigzag, right? Is it same? Is it same? This one and this one.
Same.
Yes, same.
Okay, so and the angle, both angle, okay, rotates, both angle rotate clockwise. Both angle rotates clockwise. Both angle rotate clockwise, and the moment at both fixed end, okay, are actually opposite with the angle. Can you see that? To push back. Okay, this is the fixed end moment. This is FEM. Okay, the dark blue. This is FEM. The FEM. And the angle is, okay, the angle is the maroon. The maroon, yeah. The maroon one, the angle positive, the FEM negative. Means that between chord rotation and moment, okay, between these two are always opposite. Opposite means that whenever you want to identify the direction or the sign for FEM due to settlement or due to delta or due to side sway, okay, the easiest way is to see the rotation, okay, the rotation, okay, whether it is rotate clockwise or anti-clockwise. In this case, whenever the beam, okay, move from its original position to new position, it rotates clockwise. Okay, it rotates clockwise, and the moment, the fixed end moment will react opposite to this angle, this chord rotation. Okay, so we can conclude that between the angle and the fixed end moment, it must be opposite condition. Can you understand that one?
Can.
Okay, so chord rotation, this is chord rotation. Okay, opposite with FEM. Chord rotation opposite with FEM. Okay, so it is just like this. And the formula for calculating the fixed end moment, there is only two formula depending on end condition. However, as I explained to you in the previous example just now, okay, we can also use the fixed end moment formula by considering both end are fixed. Okay, so here the moment is 6 EI delta over L squared. Okay, this is actually the formula for both. 6 EI delta over L squared. Okay, this is the formula. So FEM AB equal to FEM BA equal to 6 EI delta over L squared. Okay, 6 EI delta over L squared. If the delta is positive, FEM is negative. If delta means the rotation, if the chord rotation is positive, FEM is negative. Okay, negative, like this. So whenever we want to apply this condition into the beam that we have determined, we have analyzed just now, okay, we start with berapa dah? 240. Okay, we will start with draw or sketch the free body diagram. Okay, this is A, B, C, and D. A, B, C, and D. Okay, B has settled. So B, okay, move to new position, B prime. C remain the same, D remain the same. Okay, so we will have now two triangular for the settlement. Okay, two triangular. Here is the first one. Okay, and then we have another one like this. Okay. Okay, due to the settlement at B, normally for the settlement, for the delta, for FEM due to delta, we must find where is the triangular in the system, the triangular. Okay, because whenever we want to calculate the FEM due to delta, okay, it must be the triangular have the perpendicular, okay, perpendicular section, okay, 90 degree, and then we have to identify the chord rotation, and then from the chord rotation, from the direction of the chord rotation, the angle, we will identify the fixed end moment direction. Okay. Okay, now we have A, B, B, C. So yang affected is actually two members. Okay, member AB and member BC. Means that we will have the new value, okay, of FEM. So we will have FEM. We will have FEM. FEM AB equal to FEM BA. So this is one value. Okay, and then we also have new value of FEM BC and CB. FEM BC, FEM CB. Okay, and then CD remains 0. FEM CD, FEM DC remains 0 because there is no settlement, not affected. Not affected. Okay, AB. Okay, look at AB. AB ni, the direction is like this. The beam after settlement is like this. The beam after settlement like this, so we identify the angle clockwise. Clockwise. Okay, the angle is clockwise. So FEM is negative. So it is 6 EI delta over L squared like this. This is AB. A and B. Okay, understand this? Understand this?
Yeah.
Okay.
Yes, madam.
Okay, for BC, so now we have BC. BC is like this, right? The bottom line, okay, here is, okay, the reference or the horizontal line. The angle will be measured from horizontal. Okay, from horizontal. The angle negative or positive? The angle?
Positive.
Angle positive. Angle positive, FEM positive, negative? Angle negative, FEM positive or negative? When angle is negative, FEM
Positive.
positive. So put positive here. 6. 6 times 2 kan tadi? 2 E I delta over L. Ini CB lah. CB or BC. Same. BC AB. Okay. So we must understand about the behavior of the beam after settlement. Okay, please look at the behavior, and the easiest way to identify the sign of FEM will be based on the chord rotation. Okay, just draw the beam after settlement. Okay, the new inclined line, okay, of beam after the beam is settled, and then from that, okay, mark the horizontal line. Mark the horizontal line at A and B at both ends, and then identify the angle. Identify the angle, and when angle is positive, FEM. When angle is positive, FEM is negative, and when angle is negative, FEM is positive. Clear that one?
Clear, madam.
Okay. So I want you to continue. Okay, continue means that in the table. Okay, if you have set the table for calculate this value, okay, it can be done. It can be done either by changing the FEM value, put the total FEM here, okay, or you can also make another table. One for the first one for external load, the second one for settlement, and then the total moment, the end moment, you will have two end moment, and then you plus both, okay, plus both end moment. Or you can also change this FEM by putting the new FEM value, means that for AB it will have the same, the new value, right? AB until CB ni. Okay, due to settlement, we will have the new value of FEM considering external loading as well as settlement. Kan? So it will change this 4 value, and whenever you change this value, of course, the Excel will automatically, okay, give you the new value after considering the settlement in this beam. Okay, can you do that?
Boleh, madam.
Okay, so nanti you please continue to calculate FEMABBA and then FEMBCCB. Okay, total the FEM, both FEM, and change the FEM value, and then you will get, of course, you will get the new value of end moment. Okay, and the final value, okay, please comment in the team channel, team channel. Okay, just post the new answer in the conversation. Can you do that?
Boleh, madam.
Boleh. Okay, now is the photo session time. I want to change the setting back so that you can switch on your camera. Wait, yeah. Okay, you can now switch on your camera. Okay, where are the rest? There are more than 30. Wait, wait. I want to take from phone first. Okay, where are the rest? Please switch on camera for the photo session for today. Where else? Who else? Okay, lagi? Pendek sangat pula. Kejap. Okay. Okay. Okay, ready ya? 1, 2, 3. Sekejap, saya crop. Okay. So I put in the conversation. Okay, another scene eh. Okay, one more time. 1, 2, 3. Okay, wait. Okay, remain the same. I want to pick one more photo from my handphone. Okay, don't switch off your camera. Don't switch off your camera. Okay. 1, 2, 3. Okay, wait. Okay, one more. 1, 2. 1, 2, 3. Okay. So that's all for today. Thank you very much. Please answer the question given and comment in the conversation box. Okay, inshallah we will meet again next week. And please answer the exercise. I will extend the due date for the exercise given last weekend. Okay, for you to answer based on today's discussion. Okay, that's all for today's session. We close our session with Tasbih Kifara and Surah Wal As.